So in this video, we are going to be talking about approximations. So approximations is this cool concept which actually helps us in calculations and many problems in math. And yeah, so let's just get on with it, right? So usually, this is what approximation talks about. Now, usually the slope of any line tan theta is equal to delta y by delta x. Now, what approximation does or do is that we can equate this to dy by dx. Now, the cool part is, I mean, not the cool part or the awesome part is, this is not exactly accurate, right? Because if we have one point over here and if you have another point over here, this is the slope between them. But essentially, this is the slope at that point. So basically, this slope or the m at this m1 and at the m2 at this m1 is not equal to m2, but we can say that m1 is approximately equal to m2, so that's where the approximations come in, right? So yeah, what we actually do is we are making this approximation by saying that when we use this delta y by delta x and when we use this dy by dx at this point in x, let's say this x1, we can equate delta y by delta x is equal to dy by dx. So this is also like saying if this function is f of x, this is like saying f of x plus a minus f of x divided by a. Now what's that? A is this. A is this distance over here. And this, if this is x, let's say this is x, so this should be x plus a. And essentially this should be f of x plus a, and this should be f of x. So yeah, so we have f of x plus a minus f of x divided by a is equal to f dash of x, because that's equal to dy by dx, right? So let's just clear things up a little. We have f of x plus a is equal to f of x plus a times f dash of x. Now, and this is so crucial. I'm going to show you how this actually helps us calculate square roots in just about 2 to 3 seconds. Now, this formula is not basically a formula if you understand it. What this says is that f of x plus a is equal to this value, this value, I don't know what was that, this value, that's f of x plus a times this value, the amount it climbs times the amount it climbs or the slope it rises, which gives us this value, f of x plus a. That's what the, it's getting too congested, let's just rub things out a little, but let's keep this in our minds. Alright, so let's just rub this. I rub this, and I'm gonna use another function, which is the root function, or f of x is equal to square root of x, the square root function, and that's a pretty interesting function too. You'll see how it goes down. Let's just rub this first. Yeah, so finally we have rubbed it, and let's move on. So this was the formula, f of x plus h, let's just say the h is the distance moved on the x-axis, is equal to f of x plus h times f dash of x. And this helps us tremendously, because let's say we have a function like this. Now this is the root x function, which is ever increasing. It's always increasing, because as x increases, of course, root x has to increase. So this is our root of x function. F of x is equal to square root of x. Now what's so interesting is, if we have one value, let's say x is equal to 4 at this point, what will y be, or what will f of x be? Well, of course it'll be root of 4, which will be 2. So this point is 2 comma 4. But then we may come across some problem where we have our x is equal to, let's say, a number like 62. If you have 62, so what will be root of 62? Well, we don't know that because it's not a perfect square. So we can find out root of 62 with the help of approximations. And it's actually pretty interesting because if we know what is f dash of x, which we do because f dash of x, that is the derivative of root x, will be 1 by 2 root x, right? We can do something like this. We can say that f of x plus h is equal to f of x plus h times 1 by 2 root x, or root of x plus h is equal to root of x plus h divided by 2 root of x. I hope you can see what I'm hinting at. What I mean to say is, if we know this value, which is very crucial because if we know this value, root of x, and if we have a normal h, we can calculate this very easily. So what I mean to say is, when we have to calculate root of 62, what we do know is root of 64, that's 8, right? So we know that 64 is right beside this. So we can make an approximation that if we take x is equal to 64, we know that f of x plus, or f of x at that point, at f of 64 is equal to 8. And here we don't know the value. So let's say that this point is like question mark, comma, 62, and the next point should be 8, comma, 64. So what we are saying is, what I mean to say is that the derivative at this point is the same as the slope of these two. So yeah, that's what I mean to say. So basically the derivative of that point is the slope of these two, the derivative of this point. Now that's an approximation, right? And that's what the approximation we are going to make. So we can say that 64 minus 2, which is equal to root of 62, is equal to root of 64 plus minus 2, because we're going down, 2 root of 64. And we know all these values. That's 8 minus 2 by 2 times 8. It's 1, 1. And which is equal to 8 minus 0.125, which is equal to 7.875. And that is approximately root of 62. How amazing is that? We actually calculated the roots in just like 5 seconds. I mean, let's do another question, right? Because I really want to do another question. I want to show you guys that how helpful this is. So we'll use a similar example. Let's say we have the cube root function now, because that's also a problem we encounter in a lot of subjects like chemistry, physics, and thermodynamics. So let's try using that now. Alright, so let me just draw the function in a good color. Yeah, so we have that. And this should be a little bit more like this. So, and this is also ever increasing because as x increases, cube root of x has to increase. So this is cube root of x, which can also be written as x to the 1 by third. Now, according to this, the approximations formula, what is f of x, f dash of x? It's 1 by 3 times x of 1 by 3 minus 1, which is equal to 1 by 3 of x minus 2 by 3 to the minus 2 by 3, which is also equal to 1 by 3 x square cube root, right? So yeah, we have these values, and well, let's just get on with the approximation, right? So if we want to find, let's say, root of, well, what are the values we know? We know the cube roots of some 8, 1, then we have 27, 64, 125, then 6 is 216, then 343, 512, and it goes on, right? So these are the values we know on the x-axis. These are some of the values we know. So basically, if we have a value near these values, we have to find the perfect cube near the number we have to perform the calculation on. So let's say we have some number, let's say like 352. All right. So if you have 352 on the x is equal to 352, Which one is nearer to it? Is it 344, 343 or 512? So to make a better approximation with the slope, because if the slope is, if the slope is similar, then it's a better approximation, right? Because you don't want the slope to be like this and one slope to be like this, because that's a very bad approximation. That's not a good approximation. So if you have x is equal to 342, we want this close to 343, because that'll allow us to make a good approximation. So all right, I'll take another value just for the example. Yeah. So let's say we have x equal to, let's generate a random number, well, 130. So if you have x is equal to 130 over here, that's x is equal to 130, we need to find the cube root of 130. And we know that 125 is a value near that. How awesome is that, right? Because if you have a value near that, we can actually find the cube root, because we can make a rough approximation. So we know the cube root function can be written as x plus h is equal to cube root of x plus h times 1 by f dash of x, which is this value over here. So I just clear some things up. I just remove this. X is equal to, we can say that if x is equal to 130 over here, so we have cube root of 125 plus 5 is equal to cube root of 125 cube plus 5 times 1 divided by 3 times 125 cubed whole squared. And yeah, I'm at a shortage of space, so I'll just rub some things. So if we rub this, we get that these values, we can get that these values, well, that'll be cube root of 130 is equal to 5 plus 5 divided by 3 times 5 square. How much is that? Plus 25. So when we divide this, we can get 5. That's 5 plus 1 by 15, which is 76 by 15. And well, that is a rough approximation. So if we calculate that, we have our answer. And how simple was that? Because this is something irrational, and we just converted it to something rational, and we made a rough approximation with differentiation. So well, you can use these in many computations, and well, I hope you like this video. You share with your friends, because it is pretty helpful, and it helps me when I have to calculate square roots and cube roots. So I hope you like this video. Please share, like, comment, subscribe, and I shall see you in the next video. Goodbye.